good evening, everyone, and a very warm welcome to you all. I'm very honored to be hosting this session with the topic of enhancing mining efficiency through the combination of drone autonomy and AI. A really great privilege to be here with, and a big thanks to Nitin and the team for hosting this next gen session. Thanks, Natasha. Next slide, please. I thought I would kind of start off the presentation with a poll, a little bit of a controversial question, and I'm very keen to get a lot of your feedback to know who's in the room today. But really, to get us kick-started, I'm very interested to know, how do many of you think that the implementation of autonomous systems and AI in general really will impact the workforce, specifically in the mining industry? Will it create new jobs, with more specifically in fields like data analytics and maintenance career paths? Will it displace workers, where autonomous technology will really sort of replace the people on the ground, because technology just can do it a lot faster and quicker and safer than what humans can? Or C, will it have no significant impact on the workforce at all? If you click on the right there, you'll see next to there's three little options: chat, polls, and QA. If you could just put it into the polls there, and we'll swing around back to this later. Thanks, Natasha. So looking at the next slide, a little bit about us and who we are. So my name is Chris Clark. I'm the CEO of Delta Drone International, which is a global drone mining services provider to mining companies across the world. We started the business in South Africa and grew it up through Africa and into Ghana, and we're now currently based out of Australia, with offices in Perth and Adelaide. And we're listed on the Australian Stock Exchange, and really this business has been going for 10 years, built on the precipice of being able to do everything for the customers, really from the regulations to the maintenance. We're really sort of position ourselves as full integrators in how we deploy these solutions to the mining industry. Thanks, Natasha. So a little bit of brief overview of the mining industry for those who may be unfamiliar. While mining may not really be a sexy subject and generally a first-time career choice, we really got to sort of consider mining as really one of those sort of baseline sort of industries. It's a really important contributor to not only our local but the global economy at large. While many of us may think like mining doesn't sound so sexy, if you think about how we're going to create the batteries, the lithium batteries, the electric vehicles of the future, this all comes from very highly intensive mining, and how we disturb the environment and how we remove the topsoil to get to those ore bodies in a particular way. We're becoming a lot more focused in the mining industry on efficiency and being better custodians of the land and the resources and the environment in which we operate. So you're finding a lot more focus on these soft and hard factors such as ESG, which tends to put a lot of these sort of pressures on the mining industry. So it's a very interesting space to be in mining, where we need to get product out of the ground. We need to create new products. We need growth. We need our economies to grow. But how do we do this in a sustainable manner, taking into account a lot of these other factors and how mining impacts people and our economies and the environment around us? Thanks, Natasha. So one of the very interesting things when we started about 11 years ago was we really underestimated the sort of the immediate impact that drones would have in the mining industry. When we I sort of remember the first day when we sort of got introduced to this technology. I remember walking into a surveying office and I remember seeing this broken drone on the floor, lying in 1,000 pieces all over the place. And I remember saying to the chief surveyor at the time, I said, Jacques, what happened here? And he said, well, we bought this drone. It was a really big, it was like a hexacopter. And he said it was cost him like 50,000 US at the time. I think it was the days before, I think when DJI still had those M600s and very developmental platforms. And he said, we bought this drone. They said it was the easiest drone in the world to fly. And I remember saying to Jacques, I said, but if it's so easy to fly, why is it lying all over the floor in a million pieces? And he said, look, it was very easy to fly, it just wasn't so easy to land. And I remember at that sort of time, that light bulb moment saying, well, drones, and for many of us here on involved in the drone industry, there's this sort of perception that you can just really sometimes take these things off the shelf and start flying immediately. But many of us really kind of sort of fail to recognize that sometimes the customer's not necessarily always just looking for a drone. They're looking for what that actual drone produces, which is that data, it's that photo, it's that output and how that is come across within the industry. And we realized this quite early on that, it wasn't always just necessarily about the drone and the drone tech and the hardware itself, but it's about the actual output in which gets delivered. And mining has been one of those industries which has really grappled onto drones so quickly because of its immediate safety benefits that it provided. If you take in context, if you wanted to calculate the volume of a stockpile and how essentially how much a mine is digging out of the ground, you would have to send men who would manually walk these 30, 40 meter high stockpiles. Sometimes these could be coal stockpiles, really, which sort of had the propensity to spontaneously combust. So your shoes would be melting even as you're walking over these stockpiles. And drones immediately being able to remove these sort of surveyors off of these stockpiles to give that immediate sort of safety value. And we really were quite excited in how drones have just become part of the day-to-day norm in the mining industry and are only growing. Thanks, Natasha. So when we're talking about drones and drone autonomy, this is the really exciting sort of aspect of drones is, when we first sort of started playing with them, they became a very manual, if not sort of a toy-based sort of product. We would have, sort of our fingers and manual sort of inputs in there, and these slowly progressed into being a lot more assisted sort of systems, right? So when a lot of, if you think about in legal terms, we talk about an RPA or remote pilot aircraft, or an RPAS, which is a remotely piloted aircraft system. And the reason why you're hearing maybe a lot of that sort of legal jargon is because they realize that drones don't just operate on their own, but they operate within an ecosystem of sensors and software, which helps the drones provide a lot of assistance to the pilot in the way in which it operates. And that has brought on this real advent with the improvement of these sensors and the software, as well as flight planning software as well. That drones have now have moved from this manual and assisted and semi-autonomous sort of fashion, really to what we're seeing today is an autonomous and soon a fully autonomous system. And when we're referring to a fully autonomous system, we're referring to drones that can operate on schedule. They've got they're fully integrated with detect and avoid systems, so they can operate safely within the airspace, within predefined sort of parameters, and be able to carry out missions without any kind of human intervention at all. Now, there's a lot of regulation, which we'll chat about now, that's involved in getting into this level. Again, when you're looking at RPA or a drone, you can again look at it the whole system, which involves the software, the hardware, and the regulations as well within that. And but we're seeing a lot more regulators being a lot more open to these autonomous and fully autonomous systems, which really makes it quite exciting. And this autonomy is just one single ingredient of what you integrate into your overall offering to the customer. Thanks, Natasha. So another ingredient which you want to consider is, again, coming back to the original story, the customers don't necessarily always want to just buy the hardware. It's about the data. It's the problem that you're trying to solve at the end of the day. And what we are, shame is everyone, I hope everyone can hear me okay on the side there. So what you want to look at is, what is the actual problem that you're trying to solve? And that's really is around focus around the data element, the questions that you need to answer for the customers. And so when we started our original business, we were sort of really processing in a very singular sort of fashion. We'd go out, collect, take a lot of photos, come back, process, and output 3D models or 3D point clouds, and so it was already sort of a 1-2 step sort of process. But what's very interesting about the mining environment is that it's a very complex and very dangerous kind of environment. It's constantly changing. The road that may be here today may not be there tomorrow. So 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 everyone who's trained to operate or even to drive on a mine has to be very keenly and acutely aware of this changing environment, and what may be happening around them. And what this challenging and very fast moving environment creates is an opportunity for very, very frequent data. And when you start flying your drones every single day in a mining environment, there becomes a bit of a sense of information overload, because while you may get a very nice picture and a visualized sense of what the mine may look like, at the end of the day, the mine needs to make a decision. They need to calculate the difference between what happened yesterday and where the mine is today, and what is the trend and where that is going. And this is a really unique part of but where artificial intelligence, or AI, now comes into play, because AI is able to take all these models, all these data sets that you're capturing on a daily basis, and be able to synthesize information between each of those models to be able to give you a recommendation, or at least a red flag. AI is not perfect. I mean, I don't believe it's we're at the level of Terminator yet, where we think robots will be taking over the world just yet. But AI is definitely giving humans the ability to work a lot faster and make and process a lot of information in a shorter space of time. And this is where we're seeing it very exciting coming into the mining environment. Thanks, Natasha. So if you take these two ingredients, right? So it's the drone autonomy and the AI, and now you combine them together, we have a very special sort of recipe that now starts to form. Because what you're starting to do is, if you take AI models, let's say, for example, in this particular image, which is detecting people and vehicles, and you're applying them in onto a thermal sensor as well, you're able to start using applications within security. So what this means is that you can deploy boxes and autonomous solutions to a mine site, or to many other, let's say, even kind of dangerous areas as well. Be able to fly these drones on a very frequent basis, and let them fly and stream, and only stop and trigger once they've actually detected a vehicle or a person or a particular situation. And this is what creates a very interesting sort of opportunity for drones and drone autonomy and AI combined together. Thanks, Natasha. So combining this sort of all together and thinking about a lot of these opportunities that we sort of seeing, where you're able to deploy drones on a very frequent sort of basis, but as well as overlay these AI layers, what would you think would be the most promising applications of this autonomous technologies in AI in the mining industry? Do you really see there's just the primary focus is going to be around the safety and reducing accidents as the main driver for autonomous technologies and AI in the mining industry? Or B, do you think it could be in the productivity and efficiency? Another interesting sort of angle to look at it is the decreasing environmental impact, increasing sustainability. Because the more information that we have, the more that we know about how much we're impacting the environment, the quicker we can take to put in those short-term interval controls, or the ability to rectify it before the problem gets too big enough. Because sometimes we don't know, and drones get that really great aerial view to understand how we are impacting on within our environment. So taking, I guess, a bit of a look at the, I'm not sure about the polls at the moment, how they're sort of tracking at the moment, Natasha, but it would be very interesting to sort of note where everyone sort of stands in, I think, within the first poll. But I think we'll probably come around to that one. Thanks, Natasha. We'll go to the next slide. So this all sounds really well and great and very sexy, but there's definitely going to be some challenges in implementing this, because again, while a lot of these products that you look at look very, very sexy and very easy to use, and typically they're being sold as off the shelf, I think for many of us in industry, no, this is not generally always the case. There's a lot of integration involved. There's a lot of regulatory hurdles. You're going to hear terms like beyond visual line of sight, implementing your remote operating centers. Some of us operate in jurisdictions where this is not a concern, but for many of us, flying drones, I mean, remotely without a pilot, without someone to be there to check the weather, to check the airspace, it really frightens a lot of regulatory authorities, and the ability to prove this puts a lot more pressure on you as the organization, because you have to prove you've got to be able to simulate a pilot as if they're on site, and how we operate these autonomous systems remotely as well. Again, on the second point there, the key thing is we're not here to sell drones. We're really here about selling the data. We're here to solve a problem, detect gas leaks, detect intruders. We're here to really understand the problem is not only just gathering the data, but also making sense of it. IBM coined a very interesting term where we don't just have something called AI, but we have something called XAI, which in other words responds to explainable AI. So AI that not only can just output a result, but actually a result that you're able to track back step by step. You're able to validate the AI's methodology and how it got to that particular answer. Because sometimes people think about AI as this big black box. You throw a lot of problems in and you get an answer out, and thus the machine must be right. But there's a lot of customers and engineers out there that want to understand the steps to how did the AI get that answer. And it's really important that we all understand the same way how we understand the fundamentals of batteries going to drones, and how lithium batteries should be handled and taken care of, and charging in 40-degree heat will lead to a certain situation of probably the battery degrading and over time. It's the same with computer systems and programming. Is we've got to be able to break those apart and into their basic fundamentals, and to be able to help the customer deliver them a consistent answer day after day. When you're deploying a lot of these drone-in-the-box systems, you also got to consider the infrastructure. It's not just about the box themselves. We're seeing a lot of requirements around weather systems, around connectivity, and especially even power and off the grid, depending on a lot of the countries that you go into, and the safety of these systems and the wind impact of this as well. What's quite interesting is to then see the sort of the cost base of either taking a single pilot on a drone and going out to site, versus deploying the box, which requires a lot more capital investment to set up these permanent sort of installations, but they're not only recovered over time. So you're going to find that there's going to be a particular niche of applications which are going to be well suited to this, which is going to speak to the high frequency of that data capture. And that's where AI comes in, and why it's such a valuable proposition, because if you're deploying a lot of these nested solutions, AI is going to help you just process that data a lot quicker. What's going to be very interesting is that skills and that knowledge gap. When we sort of chatted about the poll one, it was it really was about what do you do with the current people on site, because you're going to have these new systems, these new electronics deployed. You're going to have a lot more information and a lot more data coming through. Who's going to make the final decision? Because you're still going to need a human being who's going to supervise a lot of the equipment and those methods. And the last one speaks to integration and interoperability. A lot of customers have spent a lot of time setting up a lot of their geospatial systems, their security systems. How does your offering then speak within that and integrate into the customer's API and present accordingly? Because remember, at the end of the day, the customer is not looking for the drone; they're looking for the data and that particular output. Thank you, Natasha. So that sort of leads on to our first case study of today, which is Rio Tinto's Mine of the Future program, and really regards to the recently launched Gudai-Darri mine up in the Pilbara in Western Australia. And what you're seeing is a lot of these big international mining companies, they're really about finding this efficiency. They want to be paying back dividends back to shareholders. So it's all about finding the efficiency in which you can and how you can extract the product and rehabilitate the land as cheaply and as cost effectively as possible, really. So there's been a very big drive recently into to to deploying autonomous drills and water carts. And autonomous drills is really about having high precision GPSs. You're removing people out of the drills, so you've got less drill errors. Less errors means less wastage. We're then looking at deploying autonomous haul trucks and trains. So instead of having people just being truck drivers inside inside the pit, which instinctively is a very dangerous area. If you think about if you're working sort of like 400 meters down in a pit, they have rock falls all the time, and it's really been about sort of how do we remove people out of the pit. But what was quite interesting with, especially like sort of in Rio's case, a lot of the original support for autonomous systems was around cost cutting. And you're going to actually hear that a lot today, that the reason why a lot of people say, well, reason why we want to go autonomous is we want to cut costs. And actually what we find quite interestingly, especially in Rio's sort of case, was that was probably the primary driver for deploying autonomous systems. Was yes, we spend a lot of capital up front now, and we deploy these autonomous systems and we'll save on labor over time. But actually what was quite interesting is let's take in case in point the autonomous haul trucks. If you're a truck driver on a mine driving a truck, over time as a human, you get to feel that truck, you get to understand the vibrations, you get to know when things don't feel quite right. So even before there's sort of smoke coming out of the engines, you already know something's not great and you need to take the truck to the workshop. But in an autonomous situation, there is no sensors or initial sensors. The truck goes until it breaks down, until it's done. And so what they generally found in sort of Rio's case is when they started deploying these autonomous trucks in the beginning, they had a lot of breakdowns which were occurring, and some which you had to replace whole engines or whole parts. And they started to become a lot more reliant on installing a lot more sensors, so vibration sensors and visual sensors. It really became, not just implementing an autonomous system, but it became implementing more monitoring systems. And actually, at the end of the day, when they actually calculated the number of people that they removed out of trucks, but versus what they then put into remote operating centers, they actually found out that they were employing 5% more people in managing autonomous systems than they were in truck drivers, which they replaced. Which makes for such a fascinating sort of finding point, because here we're thinking that that autonomy is here to replace everyone's jobs, but it actually just it really just changed the perspective of where those jobs went, which became a lot more really about putting those people into these remote and safer areas and nice air-conditioned offices, sitting at a screen and driving the trucks remotely rather than on site. Thanks, Natasha. A similar thing could be sent with Barrick's gold digital transformation. This is a really big global gold mining company as well, which has invested in very similar technologies such as autonomous haulage systems. But what they've done is they've taken it one step further, and Barrick Gold is actually deployed. It comes in. I sort of call it a digital twin, but it comes in very many different sort of words. And this is all really about, well, you're collecting all this information, you have these autonomous systems deployed, and you now have these sensors. How do we then decide? How do we deploy the predictive maintenance and get these real-time analytics? And it's about how these systems are all talking to one another and are visualized in a 3D sort of world. So Barrick's really taken it that one step further, and looked at how we can take efficiency and our autonomous systems and make them become a lot more proactive, a lot more predictive as well. And this also then even gets down to the point about you can't fix it unless you measure it. So So we're even getting to the point where we've got safety devices. A lot of us already wear smartwatches, but on a mining environment, we're now getting these devices which are helping us detect fatigue, detect dehydration, as well as if you're entering unsafe areas. So we're really sort of being supported by a lot of these autonomous systems, which are all working as one in a single collective. Thanks, Natasha. So what are the benefits of combining the drone autonomy and AI in the mining environment? Well, we always talk about the 4Ds. It's really about removing people from the dull, the dirty, the dangerous, and the dear. The deer refers to things that just got to be done. Like we've got to go monitoring. Someone's got to take a torch or a thermal sensor and got to go out there and monitor solar panels, or got to go walk a stockpile or around a perimeter fence. It's things that are important that you need to be done, but but where autonomous systems are really coming in and where drones play this is be able to remove people from these very dangerous situations, and things that actually become very repetitive and boring after some time as well. So we're seeing this really great benefit of automating all these asset inspections, the surveys, is monitoring the securities into, without replacing the current workflows, just make them a whole lot better and making them a whole lot more real time. Thanks, Natasha. So where do we think the future of mining and drone autonomy will go combined with AI? So as sort of mentioned in the previous slide, everything's going to become a lot more real time. Where human beings might only be doing the monitoring or the test or the survey once a month, or maybe every twice a month, we're now getting to a scenario where you can do this every day. And a lot of customers are going, well, what's really the benefit of measuring every single day? We only need our data once a month, or maybe twice a month. But the same thing could be said about the original days of when mobile networks sort of transitioned from edge to 2G to 3G. Now we're in 5G. In those very early days when we all had very basic, sort of Blackberries or Nokia phones. Natasha, you look quite young. I don't know if you ever had a 2G or 3G sort of phone, a Blackberry, but so maybe Natasha doesn't know what I'm talking about. But in those the sort of days of 2G, when you heard 3G was coming out, you said, well, all I really do on my Blackberry is I just send text messages. I'm really not too worried about any more speed. I'm very happy with just getting my text messages. But the advent of having 3G brought on new interesting inventions like the App Store and apps. And so having that extra bandwidth or that capacity for information creates more downstream applications. And that's what we're going to start seeing with drone data being available on a daily basis, is that its interoperability with other applications and the powerness of situational awareness will only improve safety, as well as the information that can be obtained from on site. And how this will all eventually play out is really into these sort of mini sort of swarms or drone fleets that are going to be able to swap between data delivery as well as then physical delivery in logistics as well within the mining environment. Because for a lot of you, those who've been on a mining environment, it's not always the sexiest place to be and not always fun. So if you're able to order your favorite fast food, or able to order snacks, the more entertaining you can make to work on a mine site, the more attractive it becomes. Thanks, Natasha. Last slide then. So in conclusion, it's really great to see how these different ingredients are all coming together to bake the perfect cake around to achieve the efficiency that the mining industry is looking for, because information is only required to become a lot faster, to make these decisions a lot more impactful, as well as to improve the overall safety. It's also really interesting to note through this as well, is that autonomy doesn't mean that people are going to necessarily lose all their jobs. It just requires that we're all going to become programmers in one way or the other. The same way how we all had to learn Office and macros at one stage, is now we're just going to learn a totally different tool set. And we're all going to be engineers to some degree or level. So I think with that, Natasha, I think go to the last slide, and I'd like to just say thank you very much to everyone and the team there as well very happy. We'd love to get your feedback. If you would like to scan the QR code there as well, please feel free to rate us and contact us as well. And we really enjoyed our time with you today. And thank you very much for your time. Thank you, Natasha.
Thank you, Chris, for this insightful session. I really hope that everyone's learned a lot from this. So without further ado, let's head over to the Q&A section. A lot of people have put in their votes and a few questions. So,
I still couldn't hear, so you might probably have to, if there was the quick Q&As.
Okay, there's a question. Can you hear me, Chris?
Put it in the chat for me if you like.
Yep. Can you see the question in the Q&A? Yep, there's a question.
So while Natasha's working on that, it's quite interesting to see the results. So people saying, what do you think of the most promising applications or autonomous applications mining? And 51% of you voted for increasing productivity and efficiency. About 40% of you said improving safety and reducing accidents, and 9% in decreasing environmental.
Chris, I've posted it in the chat.
I can't see any other questions.
Chris, I've posted it in the chat section.
It's not coming through in the chat. I don't see it in the chat session. You want to put it in the WhatsApp there for me, Natasha? Let's see.
Okay. Yep.
Perfect. Let's have a look. All right. Please provide a specific challenge within a mining environment that was solved by using drones and AI. Specific use cases, please. Hussein, there's actually quite a lot you can look for in a mining industry perspective. I think always the scenario with drones is what can't you do with drones, right? So you're combining, you've got this hardware base layer. So let's say in the Nest sort of solution, so you've got this autonomous solution that can be operated remotely. So you're really about wanting to deploy these solutions in situations where you need very frequent data results, right? That then brings on the advent of the AI, which just helps you do detections. It helps you sort of take a lot of information and be able to make decisions a lot quicker. So one of the applications which we're using this technology in is within the security sector. So flying the drones at night along perimeter fences, essentially replacing security guards, detecting vehicles, detecting people within a mining sort of environment. So really performing security controls. We also have other applications where these drones are flying every day and calculating stockpiles and stockpile volumes. Really, you can even program the AI modules as well to detect hard hats if safety is a concern as well. So the opportunities are really are limitless. It really depends on the customer and how you want to customize that last 10% as well.
Another one.
So from Rakesh, do you think multi-copters preferable in mining industries, and what is the risks with multi-copters? I think it's quite interesting. Multi-copters are definitely the biggest end of the market. It's the largest sector, especially with DJI and you're building such reliable pieces of equipment. Multi-copters are also a lot more wind resistant. So you're finding for environments where you need a high wind tolerance as well, multi-copters can exist. But when you're getting to much larger environments, again, depending on how soon that you need the data, you're never going to beat the physics of a long-range fixed-wing drone or a VTOL piece of equipment. So it's really about the kind of environment that you're deploying to. There's not going to ever be a one-size-fits-all approach. It's just really about understanding the hardware and that data capture element and understanding the environment, and then the next steps would be about processing that data. So multicopters probably will work maybe about 60 to 70% of situations, but there will be some scenarios where you're going to need a longer range piece of equipment. From Simon Pierre Dupuy, speaking of ESG, I'm curious about the uses of drones for monitoring eco remediation during mining and post-mining periods. So you're probably thinking of rehabilitation there as well, some Pierre. So yes, drones in the rehabilitation environmental have got some of the most interesting applications, especially around autonomy. What we're seeing in Australia at the moment is that even before you start mining, you can fly a drone using really high resolution, sometimes these 100 megapixel cameras, and you can actually use AI to then map the ecology. So you can actually then understand the species of plants that really exist even before you start mining. And the reason that this is important is that you're then able to quantify, and then once you're actually rehabilitating the mine, so you put back the topsoil, before you start planting the seeds, you can actually replace the exact ecology that existed before you even started mining as well. And what you're seeing is a lot of seeding drones coming to play in this. So you're able to then essentially put the GPS coordinate per seed of where that seed sprayer should deploy, and so you're returning the environment back to its original state that it was before you even started mining, which is really great. So a lot of advancements coming through. Hi, Chris. I'm based in Adelaide as well. Been doing inspection work on container cranes in the ports around Australia, building digital twins. How does autonomy and AI work in structures like this that have a lot of intricate pieces? So I think what's quite interesting on the AI component is you could, if you get one, well, let's start off first. If you think about AI in the visual sense, so training AI detectors or models to find something. So you've got to probably start off with about 20, 30 photos to just train up a basic detector. And you say, look, this is a watch, or this is a pen, or this is a crane, or bolt. You say, this is what is normal. This is the baseline. Because what you then want to do is with AI is that every time it detects something that's not what you trained on the original 20 or 30 photos, it's then going to give you this exception report. But what you find is that, you fly a drone from a different angle, or you've looked at a bolt in a different kind of sunlight, all of a sudden it throws out an exception report. And the short answer is that a lot of people have built whole businesses just on a single algorithm for looking for a particular asset within an environment. So let's take, for example, in cranes. So what you're really thinking about is, if you're thinking about sort of ideas, the autonomy can work. You can put in geofences and lots of other kind of sensors now to be able to operate in these highly complex environments. But implementing the AI component is going to be a little bit tricky, because you've got to build and train the model, and that can take sometimes between 6 and 8 months. So really got to start off with what are the big problems, the problems that are very frequent, and how do you solve those, and start off that at a very basic level. But very happy to have a cup of coffee with you, since you're in Adelaide as well. So anytime that you need. Thanks for your question. All right, I think we'll finish up with this one as well. The question is, what are the solutions to the challenges of implementing drone autonomy and AI in mining? Well, we sort of put it out on the slides there. You've got to take it step by step, because you've got to solve them all, from regulations to the communications to the integration. The challenges are there, but they're not impossible. That's why I guess we call them challenges. Is that it's just we We got to know it's more than just the box in front of you. It's more than just the software. It's a lot of these basics that you got to put into place to be able to realize a complete solution and answer to a customer. And I guess all my really sort of piece of advice is to find a particular niche that can be that can be solved, that needs to be solved on a daily basis. Sort of the original founders of Google, Larry Page and Sergey, always said they invested in businesses that were like toothpaste. Anything you needed to use more than twice a day, they felt that was the kind of the business that you needed to invest in. And I think that's where we're going to go with drone autonomy and AI in general, is to find these very high frequently use cases that really will power the business. So I know. So Natasha, I just want to say thank you from my side. You've been great, and
Thank
I
you
really
so much.
appreciate it. No, we couldn't hear each other, but I really appreciate all your help today, and thank you to everyone as well for your time.
Right. Thank you. Thank you for this informative session, Chris. I put it in the chat. We also have a Rocket Mind booth in the expo section, so you can all head there and ask your questions to the team. They'll be more than happy to help you out. So thank you. Thank you so much, Chris. Yeah, we should end.
Thank you all.
Yeah. Okay. Thank you. Bye
Ciao.
bye.